We're going to perform the horizontal line test and then talk briefly about why it's important. It's very similar to the vertical line test that you're used to. So let's start off with a couple things. We've got a function. Every one of these is going to be a function. The reason we know that they are functions is because every x has a unique y. But for something to be one-to-one, every y has to have a unique x, so it's the reverse. The evidence of something being a function is a vertical line test. And then for that function, evidence that a function is one-to-one is the horizontal line test. So we're performing the horizontal line test on functions. We're not going to have to do the vertical line test because the directions say these are functions. Are these functions one-to-one? All right, so doing the horizontal line test, I'm going to grab a horizontal line. Okay, so here's my horizontal line, and let's try this on this first one. So am I touching more than 1 point at a time ever? So I'm only touching 1 point, 1 point, 1 point, 1 point, 1 point. So I'm never touching more than 1 point at a time. So this one is considered one-to-one. Okay, so then let's move over to this one. See how when I get here, I'm in contact with 2 points at the same time? So no, this function is not one-to-one. Meaning not only does every x have a unique y, but every y has a unique x. All right, so here we go. Let's do that again. Right, see as I come down, like right here, I'm touching the graph. Here, here, here. I can only be touching it at most at 1 point at a time. So this one is, no, it's not one-to-one. Okay, then this next one, as I move it down, this curve is made out of a point, 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 point. Every point is a little lower to the left, little lower to the left, little lower to the left. Even here, little lower to the left, little lower to the left. So as you move this down, you're only touching the function at one spot at a time. So yes, this one is one-to-one. Okay, so then let's look at this parabola here. As I move that down, see how I'm touching the graph at 2 spots at the same time. So no, this is not one-to-one. Okay, let's do a few more here. Okay, so our absolute value graph, I move that down. See how I'm in contact at 2 spots at the same time? So no, not one-to-one. This piecewise function looks a little crazy, but as I go down, I'm only touching the graph at 1 point at a time. At that open dot, I'm not even touching the graph. I keep going, I'm touching only at 1 spot at a time. So yes, this is one-to-one. Okay, but then I come over here. As I come down, right now I'm only touching the graph at 1 spot, but as I keep going, see how I'm in contact in 2 different spots? Keep going, I'm in contact with 2 different spots. I can only be touching 1 spot at a time, so this one is not one-to-one. Okay, and then the last example, I've got this line. I'm touching the graph right there, I move it down, I'm touching it there, I move it down, I'm touching it there. I'm never in contact with the graph at more than 1 point at the same time. So yes, this function is one-to-one. I'm sure we're going to have to review this idea a little bit again later, but the reason why we want to know if functions are considered one-to-one, which is often abbreviated just 1-1, is because every function that is one-to-one has an inverse. And so if you're finding the inverse of a function, but your original function is not one-to-one, the only way we can have an inverse is to limit the domain. So when we start getting into inverse functions and domains of inverse functions, we do the horizontal line test as our first step. And then if it doesn't pass the horizontal line test, then we're gonna be forced to limit the domain of the original function, but we'll keep as much of that original function as possible so that it will pass the one-to-one test.